Welcome to our webinar. It's my pleasure to host together with Anna this nice webinar today, what we thought about after sales business. So this is how to optimize your aftermarket business with all integrated recognition and production on demand using 3D printing. And Nyris and Replique, we share the same vision. We want to make your after sales business easy, successful, and provide your customers a wonderful user experience. So we both recognize that if we combine our both competencies, which we will show you in a minute, we can offer a unique service to every OEM dealing with spare parts. And how? Well, let's stay curious. You see already like a slight teaser here. We will start in a minute. Just some stuff for organization. At the end of the webinar, we will make a Q&A. And please start entering your questions right away in the Zoom chat. You will hear sometimes that Anna and I talk about next slide and so on. This is because of Zoom having only one people allowing to access the slides, which will be Anna, and we will try to balance this back and forth. So I would say, Anna, let's start right away with the next slide, please.
Yeah, happy to do, Max. So yeah, I'm Anna. I'm the co-founder and CEO of Nyris. My background is engineering. I studied at the Aachen University of Technology and hold a PhD in process automation. Together with my brother Markus, I founded Nyris 6 years ago. And Nyris is a visual search platform that delivers outstanding accuracy, speed, and scalability for spare parts recognition. It works like this. Sometimes customers or service technicians are searching for parts and spares. But if your company has a huge inventory of parts that words can't possibly describe, this search can last days or even weeks. With Nyris, they can just take a photo and identify the part in less than a second. So as a machine manufacturer, you can reduce machine downtime, increase customer satisfaction with an easy ordering process, and decrease unnecessary customer service queries. So that's for us. Give over to you, Max.
Thank you, Anna. Yes, my name is Max Siebert. Background-wise, I'm a materials chemist at BASF and started my career at BASF Research and was then diverting in the direction of digital transformation. Meanwhile, I'm part of the BASF Business Incubator, and here we founded Replique. Replique is an industrial 3D printing platform, and we founded Replique to help OEMs simplifying their supply chain and being able to easily offer spare parts everywhere and to everyone. And this is how we do it. We decentralize make the production on demand by using a 3D printing network. And that means to do so that we offer a service where OEMs host their parts in a so-called digital warehouse. And once an order comes in, instead of taking a part of the physical warehouse, you now send out of the digital warehouse a design virtually to a production facility nearby. And now that sounds easy and circumvents a lot of problems like shipping, warehousing, customs, and all the things you don't like. However, you also want to keep your intellectual property. And our secret trick here is that we have incorporated an encryption that limits the number of production units and enforce manufacturing parameters for 3D printing. And even more, we record every printout and the printing parameters associated to ensure the quality for complete traceability. So lots of more secrets which are contained in there, but at the end, what's important for you, total costs for spare parts are coming down drastically. And now I hand back to Anna.
Thanks. Yeah, let's give you a little bit of background of why we think that's so important. So first of all, let's start with a quote from Harvard Business Review. So they say in industries such as automobiles or industrial machinery, companies have sold so many units over the last years that the aftermarkets have become 4 to 5 times larger than the original equipment businesses and far more profitable as well. And we see that exactly at our customers who are, for example, elevators manufacturers, where the spare part business or the after sales business in total is 80% and new equipment selling new elevators is only 20%. So same facts or the same fact, I just need to switch. Yeah, the same fact is visible when you analyze the total cost of ownership. Yeah, during the lifetime of your machine, your customers spend twice as much for service and maintenance than they do on the original equipment purchase. However, the after-sales businesses of most OEMs are not nearly as efficient as the manufacturing operations and run far behind in terms of digitizations. And that's why OEMs typically capture only a quarter of their own after-sales market. Yeah, but growing your after-sales business means growing the most profitable and less captured of your businesses. So it's worth looking into. So what's the issue? Very often the after-sales journey starts with a spare part that needs to be identified and replaced. Technicians expect a great customer experience here, same as they know from their private life when ordering online. And availability is the most critical purchasing criteria for them. Still, that's the number one. However, keeping all parts on stock and available for fast delivery is very costly. So using standard production methods, only a few parts qualify for make to order. The rest you have to make to stock, which increases again the inventory costs. So let's deep dive a little bit into the problem and the value chain.
All right. So let's just imagine you have more or less in your fabric or in your site a machine, and this machine breaks. So what do you typically do when something breaks? You either try to fix it yourself or you call a technician. And most of industrial machines have a myriad of spare parts, and so it is hard to find the right spare parts. And Anna, if you would click one forward, please. So typically what you or the technician tries to do, you try to find the right spare parts and you try to do it either in a catalog, but at some point in time, no matter if you or the technician does it, typically you end up in the helping line and in the back office, and in both cases, trying to ask for help. So that takes time, and typically, guess what? Nobody likes to be in the queue of the phone. So the support team does the best they can, and they now identify the part, but eventually they find out it's not in stock. Obviously, you insist on purchasing it, then rebuying of the machine is not an option. Training cost, delivery time, plus also just like the purchasing cost is way too high. So the support team will now try to get hold of the supplier or distributor to get a part to remanufacture it. However, it's not that you just order a single part. Typically, an OEM needs to order many parts, which is called minimum order quantity. And finally, after the OEM has received the replacement part, it takes now like some time, and then it's shipped to your spot and you receive the spare parts, which is sometimes a rare spare part. And the whole process can take up to 1 to 3 months, which is a real typical time period we are facing all the time. So remanufacturing cycles are typically in a time frame of around 100 days. All right, so thank you. So this is now the question: how can we make this easy, enjoyable, but also way more efficient? People know from their daily business how to use their phones and order and play and use it all the time. So we combined our 2 core competencies now and present you an answer that reduces the administrative and overhead costs with automated fulfillment service for ordering spare parts on demand. As I was presenting now the problem, Anna will now show you the solution.
Yeah, thank you for this benefit, Max. So yeah, let's get a closer look on what we propose. So imagine another technician is looking for a part again, and she now just snaps the part using a smartphone and the OEM's purchasing app or mobile website, where the Nyris technology is integrated. Now she gets the news that the part is no longer in stock, but can be manufactured on demand. So she orders manufacturing on demand. In the backend, the needed information is forwarded to Replique, who start a secure one-time printing process and deliver the part to her. The entire process takes maximum a week and very, very often significantly less than that. So let's talk about the magic of visual search technology a bit. Many ask us, how does that work? Is this really that good, that accurate? So our answer has always been, let's test. Yeah, we don't know upfront. We don't know your parts. We don't know how they look like. And it's always a surprise, but we are always happy to test and do that for free. So far, we managed to achieve at least 70% search accuracy for every customer we onboarded so far. And this number can go up to 95% in best cases. And that's one of our core USPs. We significantly outperform the competition here. So how do we do that? So at Nyris, we offer a very unique and highly effective solution. It consists of 4 key steps, starting with the delivery of 3D CAD models. If you got images of your parts, we're happy to use them as well. If you don't, we're happy to use the 3D CAD models, what is very often the case. We render those in a highly automated process and synthetically generate pictures out of that. So really synthetic images of that part. And those images we use then to feed the search index. Based on this synthetic index, we set up the visual search as software as a service, meaning available 24/7 to answer any request from any Nyris customer. Currently, we answer roughly 20 requests from all over the world every second. Our business model is license-driven. There are no setup costs, and the software as a service price is of a very high value. Typically, we generate an ROI of 6 to 10 times in the first year after rollout. So here is another example of our synthetic data. I just wanted to show it to you to really zoom in and show you the quality of those synthetic images, which is really not for a human eye, not distinguishable between a fake picture like this one and a real one. In a stage, this image is not real. A neural network generated this image and can do thousands of times again and again, simulating different conditions, different lighting, different backgrounds, whatever you like. And those synthetic data models remove a major bottleneck for adoption of visual search within the industrial domain. And this is a lack of real images, as many of our customers tell us. So hand over to Max.
All right, thank you, Anna. And I always really must admit, I really find this magic and amazing what you do, Anna. Okay, maybe quickly some words about 3D printing. Might happen that you're not familiar with 3D printing, and I will just briefly explain a little bit. So more or less, it's the third way of manufacturing an object. Typically, what you know are either subtractive processes, so you mill something out of a large block of material with lots of waste, or you have a so-called formative method, where you melt up material and cast it in such kind of form, either metal or polymer. And here with 3D printing, and what you can see in the image, you build an object layer by layer with different technologies. There are multiple 3D printing technologies, each of the technologies specialized to certain materials. But the principle is always the same. You always build up objects by layer, and with no installation of special part-specific, let's say, equipment. And by the way, because we are often asked this on first hand, you can print also metal. Stainless steel or aluminum, for example, are typical metal applications which are being printed. And this is like more or less how we work. The part which Anna just has identified is linked in the secure digital warehouse, which is provided. And the manufacturing methods and the suitable printer for exactly this parts are also known and automatically found near the order location. So that means once an order comes in, the order is then released to a trusted partner in our network with exact control on conditions and number of printouts. and packed in a way that's demanded by the OEM. So here what you see is the workflow end to end. You just need a mobile phone for your technicians or for your customers. And then the part can be easily identified. And if it's made, available in the digital inventory, the part can then be printed by the trusted providers. And subsequently, it can be either shipped to you or directly to the customer place in a package which you have in advance being specified. So for example, if you are an OEM, you might want to have your OEM sign on this. You want to have maybe a serial number, you get a serial number on it. And that's what we think will change the way you do after service significantly. And hereby, I would like to hand back to Anna.
Thank you, Max. Yeah, so what kind of OEM benefits, the benefits for you as manufacturing, machine manufacturer do we see? So first of all, we see the reduction of storage costs. Yeah, and here we see that on average, to store a spare part costs, or to store any kind of things or products, costs roughly 30% of the value. Yeah, so this is exactly the number we can reduce significantly, yeah, because you don't need to store the parts anymore. And we estimate that already today there is a minimum of 7% of all parts in stock that can be easily 3D printed. This number is significantly larger, depending on or can be significantly larger, depending on the material and style of your parts. Yeah, secondly, providing an excellent customer experience increases your after sales. So in A/B testing with our industrial customers, we could show an uplift of up to 25%, which is an amazing value. And last, we significantly decreased transportation distances by roughly up to 70%. That's our brief estimation on that one, due to the wide network of 3D printing facilities. So, and then we have another list of benefits, and those are the benefits for your customers or for people who use the machinery, for those technicians who are maintaining and servicing the machines. And so first of all, we provide an excellent customer experience here that leaves a wow feeling of getting things done very fast and very efficiently. And secondly, they get the parts up to 75% faster. And third, they can extend the machine lifetime, which is very important value for them. So yeah, why not starting today? And yeah, Max and me, we do have a special webinar offer today. So we offer you the chance to experience Nyris and Replique spare part service. And the offer is, please send us up to 100 cut files. We will set up the service and grant you access to the portal where you can experience visual search for all of the 100 parts. And you can order up to 3 printed parts free of charge. So, well, we talked a lot now, Max, right? So we better stop talking and love to hear your questions and answer those, whatever you might like to ask, please go on. We're happy to answer. Thank you for your attention.
Thank you so much.
I'll just jump in here. So I'm Rebecca, I work at Nyris. I'll just ask some of the questions that have been asked in the question and answer box. If anyone has any additional ones, just type them in. So one question is, how many parts can you print in a day?
Well, that's a good question. And obviously, there's a lot of, it depends in the answer. It depends of the material and the size. But what I can tell you is that we have roughly in our network 450 machines at the moment and quickly growing. And those are industrial machines. So let's say if you have like a part with the size of maybe my mobile phone, then we can print several thousand parts because we have this large network on the same day. If it's like a metal part, typically they take a little longer. And depending on the size, again, there's still several hundreds of parts possible each day. Meanwhile, we have like 30 locations around the world, covering South Africa, South America, North America, and Europe, and Asia. So yeah, we are the most important part is that we're always close to where the part is needed.
Okay, and I have a question for Anna here. So you said that the photo recognition will recognize the parts. So what happens if the AI does not recognize them?
Yeah, we always confirm. So we work as a search engine. So we send back to the user, we send back a list of possible results. And the most probable one is at the top and the less probable one is at the bottom. And so then we ask the user to confirm which one of the search results is the right one. And once the user confirms, we send the information to Replique.
Okay, and someone has asked, do you have applications in the automotive industry, i.e. clips, caps, etc.?
Is this for printing or for, for identifying, or both?
For both.
Right?
Maybe both. Anna, do you want to start?
Yeah, happy to do. Thanks, Mark. Yeah, so for example, we do work for one of the major suppliers of clips and fastenings for the automotive industry, and it is quite fascinating. I learned that yeah, they are market leader, innovation leader in that field, and those are very small metal parts. And if you see the parts, you would imagine every low budget company can produce that, but there is so much high-end inside the material that basically no one else besides them can produce it on a globally. There is no other who can do it this way, that the clips don't break that easily, and that the people who assemble the automotives can do it very fast without screwing. They just clip, and are done. But those clips look very similar to each other. And during the design process, when a Daimler construction engineer is engineering a new model, they just grab a clip that they like and test a lot of different clips. And once they defined one that they want to use for the new model, they need to identify which one is that. And then the issue starts. So very often they call the hotline, they try to look through the catalog, then try to find a service number on them, but there is no, yeah, so it starts to be problematic. And now with the Nyris tag, they just snap it and can directly use it to define which part needs to be integrated inside the new model. Yeah, and I could very much imagine that once you drive this car for whatever 3-4 years, and one of the clips get broken because you have like 4 kids of mankind and they don't really care, it would be awesome to be able to reprint it using Replique.
Yes, thank you, Anna. And indeed, we have also a case which sounds a little similar, and here I think that's also the next thing we should tackle. Actually, we are in also from BASF, we were in contact with a lot of body shops in the US in this case. And they have a frequent problem once they need to paint a car. You know, you need to take up certain parts of the car, and they're all, as Anna just nicely explained, attached by clips. And now you have like lots of different cars in your body shop with lots of different clips. And typically also what happens if the cars are a little bit older, sometimes clips tend to break, yeah, because it's polymer, and sometimes it gets a little brittle. And then it's very, very hard to replace them, to find the right one, and then to replace it. And here, this is indeed something we are trying to set up now, that we offer a range of clips which can be ordered in a very quick way and can then be delivered. So that's a frequent problem of the automotive industry. And if we take automotive as a term a little broader, we are very active in the transportation segment. And here we find a lot of parts which you cannot imagine, for example, even for trains. It really is starting from very little spacers up to parts which are in the size of, let me guess, 35 centimeters, made of metal, which is a part for the interior or exterior of a train. So meanwhile, we have quite some range of examples of different materials and sizes.
Okay, there's another question. I think it might be directed to you, Max. So what about combined materials such as co-extrusion?
Yes, it is, I would say, still to be very honest here, in a very early stage to make two materials at the same time. Co-extrusion is at the moment possible for certain methods. For example, the one you see here on the video, it's a filament deposition melting, where you can melt two materials together. For certain combinations of materials, it's working. However, if needed, we can also deconstruct a part to make two parts out of it, which are then being combined and mounted. That's a frequent method we can also offer. And also our printing partners can do some assembly steps after manufacturing the part as well. And for example, also what's a typical step is at the end adding like a sealing, which is typically made of a different material, very soft one, silicon. And here we sometimes also add this manually. In general, if you want two materials on the same time, it's not yet a very broad applicable method, I would say. But things are changing very fast.
Okay, and this one's a question for both of you. So how sustainable is this process?
That's a good one. So first of all, it's not very obvious that AI can be sustainable because first of all, any kind of AI is a compute eating monster. Yeah, so it's so how can but sustainability is very important for us. So how can we manage to keep it? And we do so with choosing a hosting provider, so the one who offer the compute power to us, to Nyris, who do have even climate positive data centers. And this is Cloud and Heat. It's a company from Dresden in Sachsen in Germany, and they use water cooling to cool down the servers. And this water heats up to a roughly 60 degrees Celsius. And then they use this warm water to heat up buildings. Yeah, and so in the winter time, it's even climate positive because they reduce the need of heating. In the summer months, it's climate neutral.
Wonderful. For the 3D printing process, maybe we conducted like a study together with the University of Mannheim and had a master thesis investigating this topic a little bit. In general, there are lots of different aspects of sustainability which you can tackle with 3D printing. Let me put it like that. If you produce a part, itself, it might not be make a big difference if you use, for example, injection molding or casting or 3D printing, because the cycle times of 3D printing are quite long and the manufacturing times of casting or injection molding is rather short. So there's not a big difference. The big difference comes actually from the shortening of transportation distances. And to avoid really overproduction and really saying, I just manufacture what I need. It's manufactured close by, so I don't have this large transportation distances. And that contributes to sustainability. The next question typically is, can you use sustainable materials? Yes, you can. For example, also recycled PET, polyethylene terephthalate, can be used. It's possible to use 3D printing also to more or less inject again materials from the different value chains inside these kind of printers. That's another part. The last method maybe sorry, on commercial sustainability. Yes, it can be commercial sustainable. Also that sometimes the parts even get cheaper because if you calculate the minimum order quantities in there, typically these parts are getting quite expensive for some OEMs. I hope this answered the question. If not, it's a long discussion that I really like to have, but I don't want to make like another talk out of that. So if you have more questions, then please feel free.
Okay, I have another question for you, Max. So do you host the printing facilities, or can we host our own in central warehouses to bring down the delivery time?
Yes, both is possible. So we can take up printers also of you. We even can install printers on your customer site. So if your customer prints more or less parts, then we can take over the invoicing, so to say, and we can ensure that the part which the customer has printed was also following the right processes and has the right quality at the end. So yeah, we can take up more or less every printer which is integrated from its APIs in our network. So here we have still some limitations by the number of printer manufacturers which our software supports, but typically we have all the major printers which you can imagine integrated.
Okay, and also related to the 3D printing, do you offer a guarantee on the 3D printed parts?
So what we are doing in terms of liability, yes. So we are liable for the parts we produce. The liability obviously is shared a little bit with the OEM because the designs are coming from the OEM. And in our process, we together with the OEMs, let's say, consult on the best material possible. And then obviously we also take the liability and therefore, yes, the guarantee that these parts have the sufficient quality. So we are the one, more or less the one contact person and contact point for you.
Okay, and this is a question for both of you. So what are the limits to both of your technologies?
Yeah, so in our case, we need to see some characteristical features which the engine classifies and understands. So if there is, if for example, to give you an example, if we would need to distinguish between TV screens and there is no logo, nothing on them, it's just a black TV screen, then we can't really say which one is which one, because there are not enough optical features that we can identify and grab to make sure that this is the one and only. But as more optical features you see in a part, as higher the accuracy we can reach.
Okay, for us, I mean, typically we have, unfortunately, still quite some limitations. First of all, it's about the size. So polymer parts which are larger than 1.5 meters require very special printers, which we also can offer at some point, but I would say the typical size of a polymer part should be way less than 1.5 meters in length or dimension. And for metal parts, it's even smaller. I think the largest metal part we can currently offer can have a maximum dimension of 800 times 400 millimeters. So that's, so far it has always been sufficient. And what you can do, so you can also obviously add some tricks here, that you more or less cut a part in 2 pieces and then at the end assemble it together. That's also an option, but it was so far never required, I have to say. The next limitation we do have in 3D printing is typically about the materials. The material selection in 3D printing is not one-to-one the same than you have in other methods at the moment, so it's more limited. I would say you can get like, I don't know, roughly 50 to 60 different materials in 3D printing, whereas you have way more, let's say, choice in other methods. But typically what we do here is that we translate, let's say, conventional materials into the available ones for 3D printing. And so far, this is also working out quite nicely. But that are the limitations we currently face.
And here we have someone asking about how secure the process is. So I guess that would be for both of you.
Process, yeah. Yeah, as we deal with cut files, so we need to care about data security, data privacy very much. Otherwise, no one would give us the cut files. And yeah, we do so. First of all, the entire data privacy is part of our product design process. So we really integrate it step by step into our product design. And we host all the data in Europe on European servers, mainly on Cloud and Heat, which I mentioned before. And we very much care about what we have a very clear data minimization or personal data or protected data minimization approach. So every time we deal with customer or user data, like for example, when somebody snaps a part with a smartphone, we delete all the information that we don't need already on device. To give you an example, a smartphone picture, for example, always has the geolocation attached to it. Always, it's given. So we delete the geolocation already on device, so it doesn't get transferred to our servers, so we can't misuse it because we don't get it. Yeah, so that's like one example of all the different steps and processes we have in place to care about the data that we process. And maybe last, we don't save the data forever. So we always ask our customers for how long they would like to keep the data saved, especially the user-generated data when users are making pictures of the parts and sending those to our servers. And our customers can decide whether that's 0, so we delete them right after the analysis, or whether that's 30 days or 60 days. And in general, by default, we delete them after 30 days.
Okay. For our process, typically we don't have these challenges of dealing with personal data, which makes our life a little more quiet, I would say. What we do, we don't host the CAD data at Replique. Actually, you do an upload. We transform these kind of data into machine-readable files for the individual printers, and then subsequently the CAD files are getting deleted again to minimize data and also to minimize the possibilities that CAD files can be accessed at some point in time. We are using a very secure network on AWS, so our whole platform is encrypted, and every file we send out via our platform to the different printers are also encrypted to ensure that the parameters, but also the number of printouts are secured. And that, I think, is at the moment like one of the highest securities possible you can apply in such a manufacturing process. And especially compared to, at the moment, present processes where sometimes you just upload a CAD file or where you just send CAD files via email. I think this now guarantees that even if the part gets printed, that you will not find copies of that parts somewhere else on the internet where people could buy them. And that's exactly what we want to do. We want to secure your intellectual property so that you can really use our reliable network in a way that you can be absolutely secure that your intellectual property and your designs stay with you. At the moment, we use at least a 256-bit encryption on the printouts. However, we have different encryption technologies available, and it more or less depends on your need of security what we should do. But the standard way is 256-bit encryption for these transfer processes.
Okay, so that was the last question. If anyone has any last questions, just write them now. Otherwise, I'd suggest Anna just goes back to the slide beforehand again.
Yep.
And reiterates the offer.
Yeah. So yeah, many thanks, Rebecca. And as said, Max and me are available via LinkedIn, via email, via phone. So whenever you have a question and would like to deep dive into the topic, we are happy to do that. So just contact us or any of our team members. And yeah, to finalize the session, thank you again for your attention. Thank you again for your time in the middle of a working day. We very much appreciate that. Yeah, would like to tell the offer again, or focus on the offer again that we like to do today. So as said, we would be very much happy to give you the possibility to experience Nyris and Replique and our joint spare parts service. To do so, you just need to send us some cut files of where you are the holder on, some of your IP, your cut files. We will synthesize them and then set up the service and grant you an access to a portal. This will be a mobile website, a demo website, and this website you can use to access the service, check the visual search and test the visual search for you, and up to 3 parts. Start the parts on demand process as well, so we get them printed at one of the facilities of Replique. So thanks a lot. Sorry, and whenever the question is there, please contact us at the Replique team or the Nyris team.
Thank you so much. Thank you so much, Anna.
Thank you, Max. All right. So yeah, thank you all and have a great day.